Hi everyone! Tonight we're going to start learning about probability and statistics. Specifically probability is what we're going to start with, and we'll work our way to statistics as we go. Okay, so we're going to start with real basics, okay, just kind of the fundamentals of probability, and work our way through some simple and complementary events as kind of an introduction to this unit. So go ahead and flip the page. Okay, here's some examples to get you started. When you flip a coin, there are two possible outcomes. You could get heads or you could get tails. Another example, when you roll a number cube, also known as a die, there are six possible outcomes. You could get a 1, 2, 3, 4, 5, or 6. You look at this color wheel here. It asks you, what are the possible colors you can get if you mix two primary colors together? Okay, we could get purple. We could get green. We could get orange. Okay, so there's three possible outcomes in that situation. Okay, looking at this spinner, it wants you to list the possible outcomes, and we want to be really specific. Okay, not only could you get a 1, 2, 3, 4, 5, 6, 7, 8, but you could also get reds or blues. Okay, so you could get a red 1, a blue 2, red 3, blue 4, red 5, blue 6, red 7, blue 8. Okay, and what we really want to start paying attention to is whether or not the outcomes are all equally likely. And what I mean by that is when you spin this, are you more likely to get a certain number or a certain color, or are they all fairly distributed? Okay, is there any number or color that has an advantage? And in this case, the answer is no. Okay, each wedge is the same size, and there's an equal number of blue and red. Okay, so we would say that this has 8 equally likely outcomes. Okay, so your chances of spinning a blue 4 is equally as likely as spinning a red 1. Okay? Now for this situation, it says you place the card shown face down, then you draw one. What are the possible outcomes? Okay, so you could pull a blue card, a green card, a purple card, a brown card, or a white card. Okay, this tells us that there are 5 types of cards. But your possible outcomes, okay, there is actually 6 of them because there's 6 cards. Okay, so that can be a little tricky. Feel free to pause, rewind, and rewatch, and then move on to the next page. Okay, we do have some vocab. I'll read them to you as you copy. Feel free to pause so that you can get them all down. Probability is the chance that something will occur. Okay, so anytime you say to someone, I wonder what the chances are that, okay, you're talking about probability. Event is one outcome or collection of outcomes, usually named with a capital letter. Okay, and we'll see that as we move through this packet. An outcome is a possible result in a probability experiment. And when you have a set of outcomes, we usually put them in the squiggly brackets. Okay, and then your sample space is the collection of all possible outcomes. Okay, and we'll work with these vocabulary terms a lot. The probability of an event is a ratio that compares the number of likely outcomes to the number of possible outcomes. And we'll be looking at that as well throughout this packet. Okay, whenever you see this notation, okay, P with parentheses, you're finding the probability of whatever it's asking you to find. Okay, the probability of flipping heads, the probability of rolling a 3, The probability of making purple with your color wheel. Okay. What's important to know about probability is that probability should always be a number between 0 and 1. Okay, if you get something else, you're wrong. So go back and check your work. Okay, and we can write our numbers as fractions. That's the most common. Decimals or percents. Okay. If you look at the chart below, it does a really nice job of explaining that. Okay, if you have a probability of 0, okay, then we say that that's impossible. Okay, so the example I was giving earlier is, what are the chances that it's going to rain grape juice? 0. Okay, or 0%. It's impossible that that's going to happen. Okay, as we move up the scale, our probability gets greater and greater and greater. Okay, so we can have anything between 0 and 1/4 fall in here. And then you make your way to 1/4, okay, which is a small probability. We know it to be 0.25 or 25%. And that's why we're saying that it's unlikely. Okay, what are the chances that you're going to have to repeat 7th grade? Okay, very unlikely. Could it technically happen? Sure. Do we expect it to? No. Okay, and then here's that funny phrase, as likely to happen as not. Okay, this is your 50-50 odds. Okay, 1/2 probability that you get heads, 1/2 probability that you get tails. Okay, so that's 50%. If something is likely, okay, then that means it's probably going to happen. Okay, so are you going, what are the chances you're going to pass 7th grade? We'd say it's likely. Okay, could something weird happen? Sure, but we expect that it's going to happen. And then for something to be certain, okay, it has a probability of 1 or 100%. Okay, it's like having one whole. Okay, and it could be something like, what are the chances that you're in 7th grade right now? 100%. It's certain. It's guaranteed. Okay, go ahead and flip the page. So now we'll do a real quick practice before we really start solving probabilities. Okay, example 1 here says picking a letter. There's 25 tiles placed face down on the table, each printed with a letter from the alphabet. You pick one letter. Let D be the event that the letter you pick is a vowel. Okay, so down here, okay, we're going to specifically separate event D from our big sample space. Okay, so the possible vowels are A, E, I, O, and U. Okay. Now event E, okay, is the event that you pick a letter that comes after the letter V. Okay, so we have W, X, Y, and Z for that one. Okay, and then this one was funny. Okay, let F be the event that the letter you pick is a consonant, okay, a non-vowel, and comes before the letter P. Okay, so if we go through our alphabets, start at A. A is a vowel, so that doesn't work. B, C, D, F, G, H, J, K, L, M, and N. Okay, so you're almost making subcategories from your big sample space that you start with. Okay. We look at example 2. Okay, choosing a vowel. Okay, Y is the event of choosing, oops, I typed that wrong. This should be choosing a prime number. Okay, Y is the event of choosing a prime number from a list of whole numbers from 1 to 20. Okay, oh, I certainly hope you know your prime numbers. Okay, but if we list 1 through 20, okay, that's your sample space, and now we're going to pull prime numbers out of it. Okay, remember a prime number is a number that only has 1 and itself as factors. Okay, so 1 is actually in its own special category, so we'll start with 2. You want to ask yourself, is there any number that goes to 2 other than 1 and 2? The answer is no, so 2 is prime. 3 is prime. 5 is prime. 7, 11, 13, 17, and 19. Okay. So this is our event, okay, but that came from our sample space, which had 20 possible numbers to start with. Okay, go ahead and try example 3 on your own. Pause the video and come back when you're ready. Okay, now that you've tried this, we can go over it. Okay, words with exactly 2 E's. You should have theme, here, there, these, and employer. Okay, and this sample space had 11 words to choose from. Once you're done with this, turn the page and we'll really dive in. Okay, so now that you have some background, we can start finding probability. Okay, actually doing some math. Okay, we're going to start with simple events. Okay, and this is an event that consists of one outcome. Okay, and remember we're going to do our likely outcomes over possible outcomes. Okay, so when rolling a die, okay, we know you could roll 1, 2, 3, 4, 5, or 6. That goes down here. Okay. What are the chances that you roll a 1? Okay, well, how many 1s are there? 1 out of how many possible values could you get? 6. So we would say the probability of rolling a 1, okay, that's what this notation means, probability of rolling a 1 is 1/6. Okay, probability of rolling a 2. How many 2s are there? 1 out of 6. So again, probability of 1/6. Probability of rolling an even number. Okay, well, how many even numbers on a die? 1, 2, 3 out of 6. Okay, so probability of getting an even is 3 out of 6, which simplifies to be 1/2. Okay, and then prime numbers. Okay, be careful on a die. Those are 2, 3, and 5. Okay, so there's also 3 prime numbers out of 6 numbers. 3 out of 6 is 1/2. And finding probability of a simple event is really that easy. On the next page, okay, you have some questions to try. Okay, I'm going to let you do those on your own. I'll be checking them tomorrow as part of your homework. But for now, I'm going to skip ahead to our last page of notes. Okay, this is where we talk about complementary events. Okay, this is where you have 2 events in which one or the other must happen, but cannot happen at the same time. Okay, so for example, you'll see down here heads and tails. Okay, you flip a coin, you could get one or the other, but never both. Okay, if the event is named K, then its complement is K with this little apostrophe looking mark. Okay. What's cool about an event and its complement is they should add up to 100% because they're opposites. Okay, I think you'll see what I mean in just a moment. Okay, when you toss a coin, what's the probability that you would flip tails? Okay, 1 out of 2, right? What's the probability that you're not flipping tails? In other words, what's the probability that you flip heads? Okay, that's also 1/2. This is the complement, the opposite of flipping tails. And when you add the two probabilities together, the probability of getting tails plus the probability of not getting tails, it certainly does equal 1 whole, or 100%. Okay, we'll do one more together, and then we'll be good to go. Rolling a die. Okay, again, you have 1, 2, 3, 4, 5, 6. The probability of not getting a 6. Okay, sometimes you'll see it with the actual word not. Sometimes you'll just see that little apostrophe, and you have to know you're looking for the complement. Okay, you want the opposite of getting a 6. Okay, well, if you're not getting a 6, you're getting a 1, 2, 3, 4, or 5. So there's 5 possibilities out of 6. On the last page here, you have a few practice problems, and I'll also be checking those tomorrow. And that's all I need from you. Have a good night.